welcome back to Level 2 Physics, looking at the external on electrical systems, today looking at circuits. Okay, so remember from last lesson in terms of combining resistors in series, essentially the total resistance is the sum of all the resistances in series, so R1 plus R2 plus R3, etc. Whereas you have to be a little bit more careful when looking at parallel resistances, because 1 over R total will equal 1 over R1 plus 1 over R2. So that means that once you get your number, you have to get the inverse of it to get the total resistance. So in our example here, on the right, so it'll be 1 over 2.4 ohms with the number you get. So you have to take the inverse again to get the total resistance, which is 2.4 ohms. Okay, so when we're dealing with more complicated series and parallel combination circuits, it's better to simplify the parallel components and make that the equivalent resistance in series. Okay, so for this example here, the total resistance of the circuit, the first thing you do is work out the resistance in parallel. So there'll be 1 over 3 plus 1 over 6. Take the inverse of that, which will give you 2 ohms. So that means the total resistance for this circuit will be 1 plus 2 plus 3, or 6 ohms. Okay, to see that as an example, in terms of calculating in series, okay, how will we do this? Well, we put in the knowns first. So the total voltage will be 12 volts. The total resistance will be the sum of all the resistances, so 2 plus 6 plus 4, okay, which is 12 ohms. Therefore, our total current will be 12 divided by 12, because using Ohm's law, current equals voltage divided by resistance, so it's 1 amp. Okay, now because it's a series circuit, the current will be the same all the way through. Okay, so I for R1 and R2 and R3 will also be 1 amp. Okay, and then we can use Ohm's law to work out the associated voltages, so 2, 6, and 4 volts respectively. And those should add up to give 12 volts. Okay, so in terms of series, it's a little bit, in terms of parallel, it's a little bit more complicated. Okay, so again, the total voltage will be 12 volts. This time, the total resistance will be 1 over 6 plus 1 over 3, taking the inverse again, because remember, that gives you 1 over R total. We want R total, so the inverse of that will give the total resistance of 2 ohms. Okay, and that means that the current will be, again, voltage over resistance using Ohm's law, so 12 divided by 6, or 2 ohms. Okay, and the voltage, because it's a parallel circuit, will be the same throughout, so R1 and R2 will also be 12 volts. We have the individual resistances for R1 and R2, so therefore we just use Ohm's law, so 12 divided by 6 will give 2 amps for the current in R1, and 12 divided by 4 will give the current for R2, which is 4 amps. Okay, so thinking about the lighting in the classroom, is it going to be in parallel or series? It will be parallel, and essentially the reason why is if one of those blows out, the light bulbs, the circuit will still go. Okay, if it was in series, they'd all go out. Okay, so the last more complicated example that you'll probably experience in exams is the combination circuits. That's where you're combining both resistance in parallel and series. So how do we do this? Well, as a step-by-step guide. Okay, the first thing we know is we know that R1 is 1 ohm, R2 is 3 ohms, R3 is 6 ohms, and R4 is also 3 ohms. And we know that the total voltage is 12 volts, okay, which I've got to put in. Okay, so the first thing we have to do is we make these equivalent resistances. So we simplify the parallel resistances into series. Okay, so 1 over 3 plus 1 over 6 equals 1 over 2 ohms. We take the inverse of that to get the total resistance in parallel, which is 2 ohms. Therefore, the total resistance will be 1 ohm plus 2 ohms plus 3 ohms for the entire system. Okay, and because of that, we can now work out the total current. Okay, so that current equals voltage divided by resistance using Ohm's law, which is the total voltage, 12 divided by 6 ohms total resistance, which gives you 2 amps. So we're on our way. Okay, so then step 3, you basically use Ohm's law to solve some ideals. Okay, so remember, you solve for the resistors in series with the battery. Okay, so those resistors in series of the battery are the 3 and the 1 ohm. So you know that in series, the current stays the same. So that means that the current is 2 amps for R1 and 2 amps also for R4. Okay, and that means that the voltage for R4 will be 2 times 3 or 6 volts using Ohm's law, and R1's voltage will be 2 times 1 or 2 volts. Okay, then step 4. Again, the total voltage in the series is the sum of all the voltages. So you again study the bigger loop this time, okay, running around, okay, from this one, the smaller loop with the 1 ohm, 6 ohms, and 3 ohms, okay. So again, the current 3 will be the voltage divided by the resistance, okay, and the reason why it is 4 volts is that it starts off being 12, it loses 6 volts. If it loses 4 volts and loses 2 volts, it means you're going to go back to 0 again, and then it gets recharged by the battery, and then we get back to 12 volts. So that means I3 has to be 4 volts over 6 ohms, or 0.67 amps. Okay. And then step 5, again, we now use the bigger loop to do exactly the same thing. So because we know R3 is 0.67, and we know that 2 amps is going in, it must mean that the current coming through R2 must be 1.33 amps. Okay, so the voltage therefore must also be 4 volts. It's in series. And we can basically check that because we know that current gets shared in a parallel circuit. Okay, and that's pretty much how we do combination circuits.